My name is Claire Evers, and I will be discussing how we are characterizing North Atlantic right whale upcalls and ambient noise levels in eastern Canadian waters. And this is done with my co-authors from Team Whale in DFO Maritimes. So we know that ambient noise levels are increasing across the world's oceans, and that noise can elicit changes in whale vocal behavior, such as in right whales. This is because whales rely so heavily on acoustics to communicate. All of the studies that have looked at the variation in call parameters in relation to background noise levels for right whales have used the upcall, and this is shown in the bottom right figure. The upcall is believed to be a contact call produced by both sexes and in all habitats. The frequencies of upcalls overlap with low-frequency shipping noise, and this means that shipping noise has the ability to mask upcalls. So to compensate for this, right whales have been found to increase call amplitudes with increasing background noise levels. The start frequencies of the upcalls in their surface active groups have also been shown to be higher in higher noise levels. Additionally, the duration and start frequencies have been found to vary across habitats in the States and Canada. And overall, the start and end frequencies have actually increased over time. And this was shown by Parks et al. 2007, who compared upcalls in 1956 to calls recorded in 2000. So the goal of our project is to provide a more current assessment of the potential effects of noise on North Atlantic right whale upcalls by specifically looking at receive call levels and upcall characteristics and seeing if changes have occurred over time by quantifying current background noise levels. To do this, we used bottom-mounted recordings collected from Emerald Basin from 2015 to 2017. The location of the recorders is shown in the red box on the map. Now, Emerald Basin is not a critical habitat, but it does appear to potentially be a high-use area, and it's possible that this habitat is used by the right whales in their migratory corridor along the Scotian Shelf while on their way to the Gulf of St. Lawrence. For upcall detection, we used an automated detector, LFDCS, to find the upcalls, and all calls were then manually validated. We then measured the received call levels and upcall center frequencies and plotted them against noise levels that were measured around each upcall. So what did we find? For in-band noise levels, which covers the frequency range of upcalls, we found that they were lower in Emerald Basin, shown on the left plot, when compared to the locations described by Parks et al. 2009, who looked at differences in upcalls across the circled habitats on the right plot. For Emerald Basin, noise was generally below 105 decibels, which is indicated by the red line on the plots. For the upcalls, we measured 477 calls and plotted the noise levels on the x-axis against the received levels of the upcalls on the y-axis. The left plot showed data from 2015 to 2016, and the right plot showed data from 2016 to 2017. Now we can see that the trends between years are generally the same. Overall, there is around 20 dB variation in the received call levels. When looking at broadband noise levels, which is the whole frequency range of our recorders, and is shown in the top two plots, there is no apparent relationship. However, for in-band noise levels, which is the frequency bands that overlap with the upcalls, we do see that received levels increase with increasing in-band noise, and this is shown in the bottom two plots. So our upcall frequency characteristics also correlated with noise. Well, when we looked at upcall center frequencies plotted against the in-band noise levels, we did not find a clear relationship. So we do have some future work that we would like to do, such as measuring additional call parameters, such as the start and end frequencies of the upcalls. We'd also like to compare different recorder locations in years. So for example, we have data from critical habitats in Canada. We'd also like to compare our findings to historical data, such as that presented by Parks et al. 2007. The biggest caveat of this project is that we only have received levels instead of source levels of the upcalls. We do, however, have future plans to deploy equipment in Roseway Basin, which will allow us to localize upcalls and measure their source levels. So in conclusion, despite the noise levels being lower in Emerald Basin than has been found in previous studies that look at right whale habitats, we did find that received levels increase with increasing in-band noise levels. There was, however, no clear relationship between center frequency and background noise levels. Thank you very much for listening, and a special thank you as well to analyst Delphine Girette-Morin from Dalhousie's Taggart Lab, who helped validate some of this data. Thank you.